I hope uh, the most of the audience are from different backgrounds, like might be from mechanical, civil, or not from IT. Okay, so I just want to make sure like everyone should understand at least some basics for the topic which we are going to learn today. Because it's common actually, nowadays everyone can understand this concept, and it's mandatory also. So like I'll just go from very scratch, like how the things are started, and at what end now we are going to see, and in future what are the things which we are going to see. All those things we will discuss here. Okay, so the first thing, like here you see, we will see about the introduction to BIM. What is BIM actually? Okay, and then BIM process and dimensions, and after that BIM 360 little bit we will see. Okay, I will just try to focus on the software also, software side, how the things can be worked, like 2D and 3D simultaneously we can work. All those things we will see. So let us begin here with introduction to BIM. Okay, first, like if you see, like previously, if you go back more than 100 years, okay, back. So we used to draw, like we used to have the plans by hand sketch. Okay, hand sketch drawing we used to have. Okay, it's like blueprint 2D drawing. So we can see on the screen. Okay, usually these are the, even if you go 20-30 years back, I had seen some drawings. When I was in a Gulf, I was just doing some as built drawings, because the installation which was done already previously 30 years, now it need to be done some modification. So we should have some drawings which already done. So that was hand sketch. Okay, so this was very common previously. Okay, but it will take a lot of time to do the hand sketch drawing, as everyone know. Okay, so now, like what I'm saying you, after this, like we used to see the 2D drawings in AutoCAD. Okay, if you see here next slide, these are the AutoCAD drawings. So still, like even the people are who are not background of mechanical civil, they know like drawings, okay, which can be presented in AutoCAD, or we used to see the printouts of the drawings, okay, before construction, all those things. Okay, like I hope everyone is getting me. Just kindly just say in chat box yes, no, so that I can proceed. Just I want to interact, just yes, no, why, and so that I can be with you. Okay, fine, fine. So now if you see here, we got here now, what is the complication here with the 2D drawings that we need to understand. Okay, that's the most important thing. Like what I'm trying to say, why we are switched to BIM from the AutoCAD. That is the most important thing we need to understand. So if you see here, next PowerPoint here, now we got here different teams, team A, team B, team C. Okay, so there are different teams. Now what does it mean actually? Like for example, previously 10 years before, BIM was not there much. Okay, so I was working in Dubai as well as in Saudi. So what we used to do, for example, I'm just giving a small example so everyone can understand here. We know architectural, structural, and MEP services. Okay, let us consider architectural, structural, and plumbing services, electrical services. All the drawings are done separately. Okay, imagine team A is architectural, structural, and this is air condition, electrical, plumbing, and firefighting. So everyone need to be do the drawing in separate AutoCAD drawings. Okay, everyone have their architecture plan. Based on that, they do the separate drawing. Then where the problem comes actually, it comes during the coordination. Okay, because imagine we got a beam, structure beam, and then we got a pipe or a duct. So it may intersect somewhere. It may intersect somewhere. So that we need to do a separate coordination drawing. Okay, that's the problem actually. So it will take a lot of time to do the coordination, like more than we can say here. Okay, we can say like more than it will take time to draw the individual service. The problem actually, imagine if there is a clash between the beam and pipe or duct. So again it has to go back to the team A to resolve this one. Then again it comes back to here. Okay, then again the coordination need to be checked. So that is checked by like manually. We should know like bottom of pipe from the slab level. Okay, from the above how much it is, that all these things need to be identified. So a lot of engineering is required for that one. Okay, that's the problem. So to resolve this, we need to switch to BIM. Okay, now what is BIM actually? Building information modeling. Okay, a lot of people they think BIM is software. but it is not like that. Okay, so what I'm trying to say, if you see here, next slide here. Okay, BIM is a process actually. Okay, it is a creating and managing information on construction project throughout its whole life cycle. Okay, you can see here, first is design, build and operate. It's about, if you're going to construct any building, it's about like life cycle of that building. So if you see here, it start from concept design. Okay, this is the first thing before construction on site. Okay, there are many things which need to be done on paper. The first thing is concept design. Okay, the second one is detailed design. Here the calculations are done. Imagine, I'm just giving you a small example. Structural analysis need to be done. How much the load is there on the structure. Okay, that need to be identified at this design stage. Okay, what should be the size of the columns, what should be the size of the beams. Okay, that need to be done in detailed design. Okay, now imagine, I'm just saying about the electrical side. We have lighting fixtures. Okay, nowadays we are using very good lighting fixtures like LED. Okay, which power consumption is very low. So that is good, but other than that, imagine if I'm using daylight. Okay, so I'm providing a windows in such a way that in daytime I can use the daylight, so that I can save more energy. So that is like we can do simulation part, that is analysis, energy simulation we do. Okay, we do a lot of things are there. I'm just trying to give the example, basic examples. Okay, so daylight, skylight, the light is coming from the roof directly to the ground. Okay, so there we don't require lighting in daytime, so we can save a lot of energy. So that is done in analysis. And then documentations. Okay, like all the calculation part, documentation, that can be done here easily. After that, like documentation, we can see the drawings also, final drawing. Okay, now after that, before we go to the construction, we need to have some material on site. That is, fabrication is done in some company, okay, in some manufacturer, and then they send it to the site. Example, pipe. Okay, pipe, the length of the pipe is, around 7 meter or 9 meter for one side, example, for one room, but it cannot become on the truck exactly 10-meter pipe, so it need to be breakdown. So that is what fabrication. So what we do, we have a fabrication drawing, and then the fabrication is done on site. Okay, after that, it comes on site, and then we start installation. So this is construction. Okay, after fabrication we come to the construction, and the construction is done. After that, we got logistics, and then we have, like, how the things need to be processed, and we got operation and maintenance. After construction, the most difficult part is operation and maintenance. Okay, now imagine, after so many years, we can do renovation and we can demolish also. So this is what BIM process. So BIM will help us to maintain all these things. So it has certain dimensions. Okay, now let us see regarding the dimensions. If you see here, okay, now previously I was saying you, if you see this one, okay, it was very difficult in this case. Now in this case, the interesting part in BIM, all the architectural, structural, and all other services can be worked in one drawing, Okay, so I mean, example, when I open the software, I will show you. Okay, architecture is working simultaneously on same drawing on the clouds. Another service can be worked, and it can be seen by architectural guy as well as structural guy. So everyone can work on same drawing on cloud basis. Okay, that is what here I'm trying to explain you. We got here, all the teams will be on same platform, so coordination will be very easy. Okay, coordination will be very easy. So this is what we have, like design. We have different dimensions of the BIM. Okay, so here I was trying to explain you just a quick. Okay, we were in, like, if you see here, we were hand sketch, then went back to AutoCAD. But in AutoCAD, the complication here is about coordination. Okay, now to resolve this one, we are coming to the BIM. So here we had learned what is BIM. BIM is a process, it is not a software. Okay, in this we have a lot of software. I will explain you about that one, but it is a process of building. And then what I'm trying to say, BIM, the most important thing, everyone can work on same platform. Okay, workflow will be very easy. So that is the main concept of BIM. Okay, I hope everyone is getting me. Please let me know yes, no. If you have any questions, I can proceed. Okay, fine. Thank you. Thank you. So let us come back here. If you see here, BIM dimensions. Okay, BIM dimensions. We had learned about 3D. Okay, now let us talk about the 4D, 5D, 6D, and 7D. Okay, just a quick. If you see here, we have 2D. 2D is, it's AutoCAD. Okay, 3D, X, Y, Z dimension. 4D is time. Okay, 5D is cost, 6D is sustainability, and 7D is facility management. If you see here, okay, it is 3D is graphical information. Okay, it is about the graphical information, and then 4D is about time and program scheduling, like what time the project start, at what time the project ends. Okay, that is very important thing. That is baseline. We use Primavera software, we use Kobe software, different softwares are there. Okay, in that we can identify when the project can start, when project can end. Just as a rule of thumb, at least we cannot say exactly, because on site the condition might be different as per real plan, but still we need to do that thing. So that comes under the 4D. Okay, 4D, 4 dimension is about the time and program information. Now when we talk about 5D, if you see, it is cost information. So definitely, like before we before we process for the execution construction, we need to know how much cost is there. Okay, so that cost information is about the 5D. Okay, so what I'm trying to say, actually it happens in real time projects, but I'm trying to say everything is done on same platform. That is what I'm trying to explain you. That is BIM. Okay, everyone can coordinate from starting to end. Okay, this is what we can do in BIM. Otherwise this process was done previously also, but different tools we were using, and need to coordinate. Okay, that was very complicated. So this is what, at one platform we are working on the things. Now 6D is about, actually 6D is sustainability. Okay, it's not time information, it's about, okay, operation and maintenance. We can say it's about operations. Okay, so it's about operation as well as, what, it's about energy simulation also. So 6D, actually this can be done after cost information. Okay, before we do the execution, or it can be done here also after 3D, like when we do energy calculations. Okay, 6D can be done. So it's about, simulation part also and operation part also. And then 7D is about, facility management. Okay, what is facility management? Means after construction we should know, like for example, you got pump, fans. So what is the warranty, what is the guarantee, how many years it can be worked easily. Okay, all those documentation should be there. So that is about the 7D. So usually BIM is divided up to 10D also, it's there, but now at present it's up to 7D. So we had learned, just a quick review: 2D AutoCAD, 3D is about the BIM Revit. Okay, it's about XYZ, and 4D is about the time. 5D, okay, is about the cost. And then if you see, 6D is about, sustainability, operations. And then 7D is about the facility management. Okay, so now next one, let us see. Okay, now if you remember, I was explaining about AutoCAD. Now it's about BIM. Okay, it's about Revit software. So if you see, in actually Revit is a software of BIM. Okay, if you see here, we have so many softwares in BIM. This is what BIM actually, you see, it uses a lot of softwares here. Okay, I hope like most of the people know some about the softwares here. So here, the more powerful tool here is about, Revit, this R. Okay, this is the most important software. So I will explain you about this part. Okay, now, okay, so if you see here, we got Naviswork also. Okay, and we have Autodesk, Civil 3D, Tekla, different softwares are there here. So we will basically discuss about the Revit here. So usually in Revit, like we can have Naviswork, okay, which is used for the clashes, and this I will explain you in detail about this one. And then Dynamo. Dynamo is what, sometime we can work backend. Okay, backend, that is on the Revit. So we use Dynamo. it's programming. Okay, so we can also use dynamo to where the revit cannot work. There we can provide the dynamo some commands, so that can be applied in the revit software. Remember, now this revit usually, we have architectural, we got structural, and we got mep. Okay, these are the three important things. Remember, okay, architectural, everyone know. Structural is about, about columns, beams, footings, foundations, everything. And mep, like most of the people, when about civil construction it comes, they think about architecture and structure, but mep is the most important part, because without this, plumbing, water supply and drainage is mandatory in the building. Electricity is mandatory in the building. For example, in Bangalore, even if you go a small shopping mall, we never see the ceiling fan. We see centralized air conditioning. So it means air conditioning is also mandatory. So in a building, all these three things need to be done. So these three things can be done simultaneously in Revit software. Okay, so let us try to understand the software here. So I'm just opening, this is a software. Okay, so I'll just give a small, I'll just try to show how powerful tool is this. Okay, let us try to understand this one. Okay, here you see I'm just going to draw some 2D drawing, so it can be appear in 3D as well as. Okay, so let us draw. Okay, so here we will go with 2D as well as 3D. So you see here, I'm just drawing here one. Okay, and I want to draw a different wall. Let us talk about curtain wall. So we can see. Okay, and here just very quick, let us draw internal wall. You see here I'm selecting the wall. Suppose if I'm using the AutoCAD, if people know about the AutoCAD, they know we work on layers. Here we are not working on the layers. Okay, now just let us place the doors. So you can see here, okay, we are placing the doors. Okay, this is what we got here, 3D. Now I'm just placing the windows here, if you see. Okay, that is just doing here. We got here window. So I want to place the window here. So we can see we got here windows. Okay, now if you see, I'll just draw here floor. Okay, this is what we got here floor. And then we will draw the roof also. Let us go to level 2. Okay, and here we will draw the roof. Struggle. So we can see we got here roof also. Okay. Now let us see, this is 3D plan and this is we got here 2D plan. Okay. Now, okay, you know what is the full form for Revit? Okay, a lot of people don't know about this one. I'll just say you about this. This is very interesting actually. Okay, see, I'm just coming here. Okay, I want to change this door. If you see, I select this door in 3D, and then what I'm doing, I'm just trying to move here. Okay, from here to here, example. So see, it moved here automatically. Okay, imagine, let us just go here. Okay, to these windows. Okay, this is window. Now, when I select the window, and I'm just trying to move here from this one to this one. So this is what revise instantly. The full form for Revit is revise instantly. Okay, when I revise in one, it automatically get updated in another part. Okay, now if you see, we had just created something here. I want here, like example, I just want to give here rooms. I will just show you one more interesting part. Okay, let us give here just 3 rooms are there here. Here we will give like, okay, we got hall 1. Let us consider this one as hall 2 and this one as hall 2. We'll just provide the like if you see here, I want to provide with the room area. So we get here room area also. You see, we got here room area. Now what I'm doing, let us just duplicate this one. Okay, I want here a small schedule. So basically, if you see, we got here this tool. In this tool, we can just provide the if I select this one color fill, you can see I want based on the spaces rooms, for example. Okay, so let us select by name. Here we can see we got this one. Now, more interesting part, I will show you. We can do the quantity takeoff very quickly. Now, just I'm giving small example. We got 4 doors. Okay, I want to know the, imagine if you got very big drawing, then it will be very interesting. Okay, so I'm just going to scheduling and quantities. Okay, and then I'm just using here doors, for example. Okay, and here I'm just providing here, okay, family, and here size. Okay, let us use here, okay, on font. Okay, and then we can provide the label also. Okay, and let us do here a label. And I want here, I'm doing quantity takeoff. You can see here. Okay, this is what you see. We got 4 doors. These are the different types, and we have total 4. So this we can represent here. In fact, if you see, I'm just opening one sheet here. Okay, where we can represent, I'm just trying to show you. We got here this drawing. Okay, and if you see, you can change the scale also. Anyhow, and then schedules which we had created, we can just print here. So this we can print actually. So when I do the print, I get the drawing as well as the quantity takeoff. Okay, so this I have done just 2D drawing to 3D drawing. Okay, and I have done the quantity takeoff. I'll just show you some more interesting part here. Brothers, are you getting me? Just please let me know yes, no. Uh,
Yes, sir.
okay, fine. Okay, I'm just trying to make it easy. Like I'm not making it complicated. Let me open here one small example. Fine. So here we can see we got here one architectural drawing. I just want to show you how powerful the tool is this. Okay, now we can draw section very quick. For example, let us start with section. Okay, I'm here going with view tab. Okay, these are the tabs actually which we use, and we have section. In AutoCAD, to draw this section, it will take around 3 to 4 hours. Now here I'm just showing it will take just few seconds. Let us just draw here one section from here to here. Okay, now what I'm doing, I'm just providing the range, and you see when I just go here, this is what we got section. See, section. And once again, I'm showing you, I'm just drawing a section. Let us consider the section here. Okay, let us go with the section, this part. Okay, and then let us just draw this section. Okay, you see this is a section. We can draw the call out. Call out is what, enlarged view. What is enlarged view? I will just show you this one. Example, I'm using here call out. This is what we got here, call out. And I'm just drawing here. Now this is what scale is enlarged here. Okay, you see now how to identify this one. I'll just show you this one. Okay, you see this is the plan. Here this is the plan. I'm just using the call out. You see, I just bring the call out here. So this is the enlarged view of this one. This is the enlarged view of this part. We can do it very, very easily. Okay. Now, once we draw the 2D drawing, automatically 3D is generated. And now another part, if you see, this is the actually one of my favorite part. Okay. I just want here camera view. So I'm just going 3D view and camera. And then I'm just selecting from here to here. You can see we got this one. Okay. Once again, I'm showing you. You can see, for example, this 3D view, and we got camera option. So we can see, like example, from this point to this point, and I'm able to see here camera view. I can change this one to shaded. Okay, and then same thing. I want here another view. So we can see, for example, from here to here, we got this camera view. Okay, so here let us see. This is the camera view. Now next one. This is which drawing? If you see, this is the ground floor. Okay, and here we got first floor. So I want to see the 3D of the ground floor and first floor differently. Usually you see this is the 3D for whole plan. You see this is the 3D for the whole plan. Okay, now if you see, just one second, just one second. Okay, so if you see, I want to see only the ground floor. So we can just switch to the ground floor. This is what we got here, ground floor. You see, we can only see the for the presentation. It is very good when we sit with the client, he can understand very easily. Okay, I want to see only first floor example. So see, this is my first floor. Now I want to see call out. A call out means, if you remember, we have done this part. That is the enlarged plan. Okay, so in 3D I want to see the call out. So when I come here, you see, I'm just going here 3D view. Okay, and and this is call out. So see, this is we got here call out. Now one more thing, if you see, we have done the section here. Okay, this section. So even we can see the section also. I want to see the section here. So see, this is what we got here section. We have which we have drawn. Okay, this is what we got here section. Now, next one, if you see here, I'm coming back now. One more thing, very interesting is about walkthrough. So see, I'm just coming to the walkthrough, and then I'm drawing here. Okay, this is what we got here. This one, and I use finish walkthrough. Now let us go to the walkthrough here, and we will see how it looks. Okay, let us see this one. Okay, this is what we can do the walkthrough also. We can change this one to MP4, and we can display in front of like clients if you want, like big projects, all those things. So this is about a walkthrough. Okay, so up to here, like everyone is okay. Please kindly let me know yes, no, something like that. Okay, fine. So fine. Now another part I will just go. Like this is I have discussed about the civil side. Now actually my background is about mechanical. Okay, I have like then most probably I'm from HVAC background. Okay, I've done my masters also from HVAC. So I'll just show you something about that one. Okay, it's very interesting. Uh, okay, so here, okay, if you see here, I'm just coming. This is what we got air conditioning. Everyone know about the air conditioning. Okay, this is we got wall mounted AC. And if you see, this is we got cassette AC. We know about this one. Okay, we used to see general in our home. But I'm just trying to show you about the centralized air condition system, how it works actually. Then I will come back to Revit software. Okay, the reason I'm not jumping directly to the Revit, so it will be quite confusing. Okay, if I don't explain this part to you. So you can see here, we got here ductable split AC. It's something okay, centralized. So if you see this, we got machine. Okay, previously if you see this air conditioning is supplying to only one room, but here multiple rooms. So this is ceiling mounted inside false ceiling. This is the machine and providing the air conditioning. See, this is what we got here. So this is one room and this is another room, and here we got air terminal diffusers. Okay, now I will just come, you can understand this one. So usually cool air moves from here. Okay, and then it comes from the supply air. You see, this is the supply air. Okay, which is cool. uh, uh, okay, the temp, usually in our home we used to set the temperature 24 degrees Celsius or 22 degrees Celsius room temperature. But the interesting part, that air which is coming from the air condition is not 24 degrees Celsius. Okay, it's about 16 degrees Celsius. But when it touches to the room, okay, example lighting fixture or electrical people, from where the heat is generated, it becomes 24 degree. We will never send the air of 24 degree to the room, because when it touches to the people lighting electrical or walls, hot walls, it might become 28 or 30, which is not comfortable for human. So a lot of people don't know about this one. Okay, so the air is coming at around 16 degrees Celsius. So this is what we got air, and then it goes back, that is 24 degree. So same thing if you see, just now I had shown, we got here flexible duct, and this is plenum box, and this is ceiling diffuser. Okay, so see the air is coming here, and then it is going back here. So you see circulation of air is there. Like I used to ask many of the people, where does hot air goes from the room? So many people, like they say it goes outside, but it's not like that. It recirculate inside the room. It recirculate. Okay, so you see, this is what it's going back to the machine. Okay, it's going back to the machine. See? So then this air is coming here. Gotcha. Okay, so this is the ductable split AC, we can say. We got here coils, cooling coils, okay, copper tubes. It may, in this we have like refrigerant gas. When hot air touches to the refrigerant gas, it becomes cool, and the fan will try to move the air. Okay, this is what the process. So this is ducting actually. If you see here, this is the ducting in real time. Uh, so you can see this one. If you try to observe, this is supply air duct, return air duct. Okay, here cool air is moving, and here 16 degrees Celsius is moving, and here 76 degrees going back. 24 degrees Celsius. So this we got here chill water piping. Okay. Now coming back to the software. Okay, let us see about the software. Okay, this we got here piping, and these are the chiller, centralized chiller. Okay, now let us come to the software. Okay, I will just take more sir, can I take just more 5 minutes? I will just take. Is it okay? 5 to 10 minutes. Fine.
Right. You can take more time. No problem.
Okay,
You have enough time.
fine, fine. So you see, we can see here like these are the diffusers. Just now I had explained, in this one. So these are the diffusers. So if you see supply, this is supply, and this is return. Okay. Now in usually in AutoCAD we have to draw, we have to connect, but in BIM software it can be done automatically. How? Let us see. If you see this 3D, I'll just show you. Let us make this one as mechanical. Now we can see here. For example, I'm just trying to select this machine. Then I'm selecting these three supply references. Okay, now what I do, I'm just going duct here. Okay, we can see generate layout. Generate layout. So see, we got here. This you see, we got options. This is one ducting layout. And if you see, we have another ducting layout. This is what, okay, and this is the third option, fourth option. So we might have multiple options. You can see we got multiple options. So let us choose here, for example, this option we will choose, and then I'm just choosing finish. So see, automatically ducting is there. Okay, now here if you see, the sizing is not done, just layout is done. So if we want to see in 2D, we can see here. This is what we got here in 2D drawing. This is 2D drawing. Okay, now if I come back here to the 3D, we can see here duct sizing. Like I'm trying to say the software does it is not only for 2D and 3D, it is also used for calculation part. This is what I'm trying to explain by this example. If you remember, I had explained 2D and 3D simultaneously for the architecture, but I did not show any calculation part to you. Here I'm showing the calculations also. So you see, we got here, duct size and pipe sizing. So it means some calculation is being done here. So when I select here, if you see, I'm just going here with 1000 FPM and I select OK. That is velocity actually, velocity. See, duct sizing is done. So here, in AutoCAD, usually we have to write down the text. What is the size of the duct, all those things. Here, just we can come here, we can provide the tagging. So automatically it will take the tagging, you see. Suppose if I change the duct size, imagine this is 15 inch by 15 inch. I'm changing the duct size here to the 16 inch by 16 inch. So you can see when the size change, automatically the tagging also is changed. It means it is automated. I'm trying to say it is automated. Okay. Now here what we can do, we can do here quantity takeoff very quick. You see, I'm doing the quantity takeoff for the ducting. So if I select here, for example, duct, and here we got, okay, system type, and then size, we got length, and then we got here area. So just let us do here, I need length and area totals. So when I select OK, you can see here, we got total area also. You see total length, total area. Okay, this we can export to Excel sheet also. Excel sheet also. Okay, so here this is about, we can do the quantity takeoff. We can do cost analysis also here. Okay, a lot of things we can do here. So now I want to show about this software. Imagine you got a pipe. Let us consider here duct. Okay, this is duct. So if you see the offset here, just let us see the offset here. It's 12 feet. Okay, so I'm drawing a pipe here of same 12 feet. Okay, let us draw here 12 feet, and I'm drawing a pipe. So it is intersecting. So imagine if you got big project and there are a lot of intersections. So what we can do, we can have an option here. If you see, we got one option, interference check. In this one, I can use the pipes and duct. So it can identify where are my clashes. So see, it is showing me these are the clashes. We can even see in 3D also. Okay, if you see here, it shows me the clashes. See this one, and here we got, and here we got. So now to resolve this one, what we need to do, we have to change the offset. Let us change the offset. Imagine it was 13 feet. Let us make this one to 12 feet. We will make this one to 10 feet, for example. Now see, when I go here with, uh, interference here, so duct and pipe. So we can see no interference detected. It means we can also do the coordination also. So what I was trying to explain in the beginning, all these services are done in one platform on this one software. Okay, by using worksite, work sharing, centralized file. Okay, there are some terminologies which we use. That is the concept here. Okay, now here, if you see this last two things, we can convert the BIM Revit software into AutoCAD. Okay, just let us see this one. I mean, the drawing we can convert directly into AutoCAD. So you see, imagine this is, we got here 3D drawing or 2D drawing, anything, okay, anything. I'm just taking 3D drawing, for example. So we got here file and export, okay, and then we can, because some client want in AutoCAD only. So I'm changing the drawing, and then I'm selecting next. Okay, let us go here and save on desktop. Let us open here the drawing, this one. So it will open this in few seconds. since this is 3D drawing, so it is taking few time, okay, few minutes. So see, this is what we got here, 3D drawing, which is in AutoCAD actually, okay, which is in AutoCAD. So this we can do very easily. Okay, you see, this is what we got here. So now I'm trying to say we can convert the 2D drawing. Okay, here you see we can go here with visual style also. Okay, we can change this one to wireframe. Okay, you see we got here wireframe. So here it is like this. Here it is like this. So this is what now the last thing I want to show you is about BIM 360. Okay, it is about the BIM collaboration. So a small video will explain you a lot of things. Okay, then I'll just finish my session. You can ask the question and answers. Okay, so this is what 360 you can see here.
What if there's a smarter, more powerful way to connect teams and data from design to construction? Where project delays, rework, and change orders can be avoided. What would it mean to deliver quality designs that meet constructability requirements? Where stakeholders can follow design progress and provide feedback without needing to access or use design tools. Meet Autodesk BIM Collaborate. It's the design review and coordination offering that helps project reviewers to view designs, manage feedback, analyze changes, and identify clashes in a single environment. It starts with better data management. On a secure cloud-based common data environment, Autodesk Docs. Get access to the latest project data. Easily create and manage markups and issues. You can rest assured your teams are aligned and progressing on the most recent comments and feedback. You'll always have visibility into design development with contextualized change analysis by easily viewing any combination of models. All of this helps reduce miscommunication, rework, and RFIs, and will improve the productivity of your design teams. For the first time ever, with a single offering, more project stakeholders can be brought into the coordination process. Valuable input from trades and construction teams is integrated early on. With automated clash detection, BIM and VDC managers can reduce the time spent on coordination. With project reviewers on BIM Collaborate and design teams on BIM Collaborate Pro, you can speed up model review, improve communication, and deliver better designs. Better design collaboration, better project coordination, better starts.
Okay, fine. So here there are some, this is what I have concluded my session. Okay, so there are some questions. Just this first question, please share the system requirement needed for working with BIM and also preferred brand of laptop and desktop. Okay, so here I just what I recommend, Dell is the best actually. Okay, Dell, and minimum 8 GB RAM is required, and graphic card inbuilt is also okay, or 2 GB graphic card. If you want to work on big projects, okay, very big projects, large projects, then 16 GB in real time. In fact, they work on 32 GB RAM, but I think 16 GB is more than enough. Okay, Dell laptop is okay, and the processor i7, okay, is okay. Okay, what is the career path for an HVAC engineer? Okay, like HVAC engineer, I can say, everywhere air conditioning is very mandatory. Okay, it's not about only HVAC engineer. We have certain stages. We might go first with HVAC engineer and then project MEP engineer after that one. So I was first as a HVAC engineer. Then I moved with HVAC, plumbing, firefighting, electrical. Okay, but if you want to move only in HVAC for career, you can go like design side. In that energy simulation part is there. Oh, so core HVAC engineering, we can do some research work, all those things. So that will be a very different aspect, and very huge value is there, demand is there for that one. Okay, so any other questions? Okay, a drawing made into the AutoCAD. Okay, while loading to Revit 3D drawing will not. No, no, no. There is a process actually. We have to do the tracing. Okay, we have to do the tracing. Suppose if you got here. Okay, I will tell you that system once again. Here, we can bring the AutoCAD file here and we have to do the tracing. I mean, it is just like, working on carbon paper. So it will get updated automatically. So we can bring AutoCAD file. Okay, it will take time, but I'm just showing we got here import CAD. From this, we can bring the CAD file, but automatically it will not generate into 3D. We have to do that tracing part. Okay. Okay. Now, does Revit offer facility for structural design and analysis? Yes, yes. You see, we got here structure and analyze. Okay, we have this one. We can see, like, this load calculation we can do here, but the precisely is done in a different software, but we can use the help. We can use this one. Is there any Autodesk international or certification preferred in industry for? Actually, there are certain exams for this one, for certification, MEP, HVAC, electrical, firefighting, plumbing, as well as for architectural structure. If you go Autodesk website, you will get the things. Okay, there was a question regarding, what system requirement. Once again, I repeat, it's minimum 8 GB RAM is required and 2 GB graphic card. And the processor, Dell we can use, i7 processor we can use. Actually, I'm using 8 GB RAM and i3 processor. So you can see my speed, how I'm working. So any other questions? So, okay. Okay. What scope do a civil engineer have a BIM? Okay, like, what I can say you, in Canada, okay, in Western countries, already people are working on civil only. I mean, already people are working on BIM Revit. So it already switched from AutoCAD to BIM. In Gulf, almost 60% is switched, and in India, it is around 40% or 30% people are working on BIM Revit. So in future, like after 5 years, might be everyone will work on Revit software only, because the thing is that a lot of people are not aware from the software. Okay, and here you see facade engineering using, yes, yes, we can use this one. So cladding, curtain wall, for sure we can use. Okay, how would be that? Yes, yes, we can use easily. Actually, nowadays, recently one of my students got selected also. Okay, she was civil engineer, so she's working on facade only, curtain wall, all those things. Okay, RAM actually, ROM would do for, yes, it's see, usually I say, like, 16 GB RAM and i7 processor, 2 GB graphic card. Any questions? Okay, yeah, it is came to know from your presentation, BIM is not a single software, it is a process. So all process of BIM can be done using, no, no, no. Revit is the most important tool. Okay, we can use different softwares also, but this is the main software which we use. After this, we can go to other software, because drawing need to be done, then we can change that drawing into all costing estimation, analysis, all those things. Okay, so also for special package for Revit people probably. Yes, actually Revit is the most important tool, I can say. Okay. Okay, I'm working as a site engineer. Yes, if you're working as site engineer, you can switch to HVAC design engineer. Okay, then it will be very good, because now you can imagine very easily. Okay, yeah, 500 GB is okay. Memory is okay, 500 GB. Okay, I'm studying Primavera, recommended for entry level engineer. Actually, Primavera is about planning. But what I suggest, once you see real time project, you go on site and see how the execution is done or how the process is done, then it is better to learn Primavera after that one. Otherwise, you will be just like doing Excel in real time if you don't know the real things. So what I suggest, at entry level, you go on site, you see how the work process is going on. Okay, what are the stages of execution, then we can switch to the Primavera. Yes, of course. Like we are academy actually. We are located in Jayanagar 4th block. Okay. You can see like I'm just providing our website deltatmep.com. Okay, you can just go through that one. You will get all the information. We actually I have provided more than 4,500 students. I have provided training to them. Okay, this time and money we will discuss like once you call, and then we will discuss about that one in detail. Time is, it's around 2 months, 2 to 3 months it will take. Okay, and we will project based training is there, project based training. Okay, anything to ask? Okay, thank you so much. I hope like most of the people got at least some knowledge from the session. Okay, so okay, that is actually, there is a calculation for that one to diffuse a supply and return. It is based on the throw, based on the throw. Yes, we can go directly to the Revit without AutoCAD experience. A lot of people are doing like that only in our academy. Engineers, fresher are coming directly switching to the BIM Revit. But at least AutoCAD commands, I recommend like if you're learning BIM Revit, just learn some basic commands of AutoCAD. It's my pleasure. So,
Abdul Majid,
G.
thanks a lot for this introduction. So, do you have plans for some more advanced and in-depth sessions also?
Yeah, actually, like how much time you require for that one? Because timing is the important thing here.
No, you can take whatever, 1.5 hours, 2 hours. It's up to you. Or if you want, we can have multiple sessions also.
Uh-huh. Okay,
Maybe
fine.
3, 4, 5, 6 sessions as per
Yeah,
your.
yeah. What we will do, we will discuss like, we have certain modules like based on the background. If we provide the training, then it will be very useful. Like for HVAC, we have different. For BIM, civil engineers, we have different. For mechanical, we have different. For electrical, we have different. And for plumbing, water supply and drainage, and for electrical side, all this we have a modules for that one. So we will discuss. We can do
Yeah.
it. We can do it that one.
Okay, inshallah. Jazakallah.
जी, जी.
So, from the participants, do we have any other questions also?
Yes, sir, please.
Yeah, please go ahead.
Sir, over to Majid sir.
जी.
So how much would this Dell laptop cost, sir, with these specifications? 8 GB, 2 GB graphic card, i7, and 500 GB memory?
Yeah, I think it costs around 60 to 70,000 nearly.
Okay.
Dell
Yeah.
laptop.
Okay. Thank you so much, sir.
Any other questions?
Okay, so this we can close the session. Thanks a lot to all the audience.
Okay.
And
Thank you so much.
thanks to Abdul Majid for taking this interesting and useful session. So, inshallah, we'll keep on having such webinars on successive Sundays. So, if anyone from the audience would also like to share their knowledge, so please do reach out to us and we can schedule your session also. With this, let's close this. Thanks a lot. Assalamu alaikum.
Walaikum assalam.